what we are learning about today is two new pieces of information about a parabola that you've never heard of before. It is called the focus and the directrix. Focus, really easy to say, but try saying the word directrix to yourself right now because you'll get tongue-tied a second. Say directrix. So it's like direct and then tricks, like tricks are for kids, directrix. Now, a parabola is created, we know, from the x squared formula. But it is also the set of all coordinate points, x and y, that are equidistant from this point that is called the focus, and a fixed line called the directrix. So a coordinate point that we're going to identify now is going to be called a focus, and a new vertical or horizontal line is going to be called the directrix. The focus is always inside the parabola. So if we were going to put a focus right here on the number 3, do you see how it is inside the U, inside the parabola? That is going to be called the focus of this parabola. It's on the inside. The directrix is a line that is on the outside of the parabola, which means it cannot touch the parabola at all. In this case, it would be a line about here. I like to draw mine in dashed. They're not necessarily dashed lines like axis of symmetries. They are actual lines. They're not invisible. They are actually there. I just like to draw them dashed so we know it's not a different linear equation. This is called the directrix. Now, what's really cool about the focus and the directrix is that they are completely related to each other. I drew these on purpose this distance away. What is the distance the vertex of this parabola, which is at 0, 0, is from the focus? How many jumps? 3 jumps, right? 1, 2, 3. So it is 3 jumps away from the vertex. How many jumps away is the directrix? Also 3. So they're both the same distance from the vertex. That's going to happen every time. And here's where parabolas get really cool. We've only ever seen parabolas that open up, happy parabolas, and open down, sad parabolas. But there are actually parabolas that go left and right. That is still a parabola, but it is no longer a function because it doesn't cross the vertical line test, or doesn't pass the vertical line test. This is called a relation, but it's still technically a parabola. These side-to-side parabolas also have focuses and directrix. So if I put my focus, I'm going to put it 3 units away from the vertex. This is now the focus of this side-to-side parabola. It's still inside the parabola's arms. The directrix is going to be outside the parabola's arms, not touching the parabola. So my directrix this time is a vertical line. So every single time we do one of these problems, the focus is inside of it. The directrix is the line outside of it. Focus is a point, directrix is a line. But specifically, they are a point and a line equidistant from the vertex. So if I look at the vertex of this graph, how many jumps did it take to get to the vertex? 3. How many jumps did it take to get to the directrix? 3. Those should be the same number every time. The distance between the vertex and the axis and the focus and the vertex and the directrix is the same. So we should be able to count a bunch of things today to be able to do some math. Okay, so we feel pretty good about identifying which one's a focus and which one's a directrix, as proven by that GIM kit. So now we're not just going to be able to point at them and say what they are. We're going to have to write equations with them. So this is a little bit difficult at first. You're going to notice some patterns here that make it actually very easy. Okay, you have kind of 2 types of parabolas. You have first the parabolas that open up and down. So those are our normal looking parabolas. Just to draw your attention to them, they're the up and the down. Let me use a different color, actually. Here's our 2 parabolas. Okay, now just like we noticed on the paper, when we have focuses, they are inside the parabola, and when we have directrix, they are outside the parabola. They are controlled all by the distance that they are from the vertex. That distance is going to be the letter P. What letter? P. P. So today we're adding in a new variable that we're working with. It's the letter P. But P is only a distance from the vertex to the focus. So if you look at these equations here, The first equation says that the focus is found at 0, comma, p, which means, is that p value on an x or on a y?
On a y.
On a y. Notice then that the equation starts with what letter? Y. And the directrix equation starts with what letter? So if the p is a y value, when we focus on the focus here, that means the equations we're going to use start with y equals. Now, you have a whole formula chart here as to how to write an equation of the line, find the focus, and find the directrix. But the main idea is being able to figure out p, the distance from the vertex to the focus. So just literally count how many spaces away the vertex is to the focus. On the other hand, you have a separate type of equation now. These parabolas that open to the left and to the right. This one opens to the right. This one opens to the left. They still have a focus on the inside and a directrix on the outside. But if you look at the equation or the coordinate point for the focus, where is the p value? Is it on the x or on the y? On the x, which means look at what's happened. Our equation this time starts with what? X equal. And what's over here that has never been over there before? What? We can do that? We can. X equal to 1 over 4p, that's where the p goes, it's important, y squared instead of a regular x squared. That's how it opens from side to side. Also, what does the equation of the directrix start with? So wherever the number is on your focus, that's the number, or that's the equation you're going to use. So if it's on the x, you use the x version. If it's on the y, you use the y version. Does that make sense? Okay, so these equations right here are probably the most important thing on your notes for today. So if you want to put like some stars around this equation, our goal is to be able to write equations for these parabolas today. Okay, so let's go to the back page. We're going to be writing equations for parabolas. The only thing we need is p, the distance from the vertex to the focus. Okay, so we're given some information here. It wants me to write an equation for the parabola. So I'm going to look back at this front page for the equation eventually. I just need to decide if I'm going to use the y equals equation or the x equals equation. So to be able to do this, we're going to do one thing and one thing only today. We are going to focus on the focus. That's pretty easy to remember, because if we focus on the focus, it will let us know which direction this parabola opens, and it will let us know which equation to use. I actually heard somebody already say it. Which version of the equation are we going to use? The x equals or the y equals? Why? Yeah, the number for p is on the y coordinate. So that means that p is going to be this number, -8. I get that number from the focus. So if I flip my paper closed, because I don't think you have these memorized yet, we said it's going to be the y equals equation. So it's going to be y equals 1 over 4p times x squared. There is only one number I have to plug in here to write this equation. What letter is it? P. What's the number that we're going to use for p in this equation? -8. So in the place of p, I'm going to write -8. Oh my gosh, that's a quick little calculator question. What is 4 times -8?
That's what, I forgot. We learned what we catch when we were young.
You did, but now you have a calculator to ask when you don't know it, and it should be -32. Okay? Y'all, that's it.
Oh, that's it?
That's it for real. We have written the equation of the parabola that has that focus and that directrix.
This will be on the test?
Yeah.
Oh, man. I'm gonna ace this.
It ain't nothing else added to this.
Not really.
Not really.
Can I show you, before we go on though, I want to show y'all what this looks like on a graph, just so you believe me, okay? So let's do another one. In number 2, which one of those coordinates am I going to focus on? The first one or the second one?
The first one.
Oh, the second one is labeled the focus. Remember, we're focusing on the focus. Uh-huh. Now, is this going to be an x equals or a y equals equation?
X equals.
Ooh, where is the number? The number is on the y side of the coordinate, so we're going to use the y equals equation from the front of my paper. What is the p value, though? 1. Just exactly whatever number is in the focus. This would be y equal to 1 over 4p times x squared. What is the only number you have to plug in?
1.
1. And where do we plug it in?
Equals 1 over 4 times 1.
Exactly where the P is. And what is 4 times 1?
4.
4 times 1 is 4. Very good. Guys, that's it. That's the parabola that has a vertex at 0, 0 and has a focus at 1.
Can we try one more?
Right.
Absolutely. You're going to try 3 and 4 by yourself.
Yeah.
Wait, I don't.
In number 3, we focus on the focus. And where is the number? Is it on the X spot or the Y spot? X spot. So I'm going to use the X equation. Make sure you notice that the X equals equation has a Y squared instead of an X squared. The variables have switched spots. But no big deal. When I do that, that means all I need to do is plug in that value for P that I found in the focus. So my equation would be X equal 1 over negative 8 Y squared. If you graphed that on Desmos, it would show you a sideways parabola that has a vertex at 0 and a focus at negative 2, 0. It would be opening to the left. Be kind of interesting. This one, interestingly enough, if you go to graph this on your calculator, it will not work because graphing calculators only graph functions, and that one is a relation. Fun fact. Now, some of us probably panicked on number 4 simply because of the number that I gave you. Did you panic a little bit? Nah? Okay, great. If we focus on the focus, is that covering X or covering Y? Y, which means my p-value is just simply the number that's there. Yes, it's a fraction, no big deal. We have calculators for this. Since it's on the Y spot, I'm going to go back to using the Y equals 1 over 4p times X squared equation. All I have to plug in, though, is that number for p. And if you don't know how to multiply fractions in your head, it's a really good thing you have a calculator. What is 4 times 3 over 2? 6. So this is just 1 over 6 x squared. All right, if we go to that 5th one and we focus on the focus, is the number covering X or covering Y? Y, which means I know the p-value is negative 2, and I know that the equation I'm going to use is the Y version, 1 over 4p x squared. So if I plug in that p, we should get Y equal to 1 over negative 8 x squared. That is the parabola that has a focus inside of it at 0, negative 2 and a directrix at Y equal 2. It'd be opening down since it's a sad parabola. Now, not always are you going to get nice, pretty numbers that are given to you like this. Occasionally, you're going to be given one piece of information, specifically a picture like this. But remember, what are we focusing on? Focus on the focus. It has labeled the focus for me because it's inside the parabola. We just need to know the distance from the focus to the vertex. What is the distance from the focus to the vertex? 5. This focus is at the coordinate point 0, 5, or it is 5 steps away from the vertex, which means what is my p-value? 5. And is that 5, since this opens up and down, does it tell me that I'm going to use the y equals or the x equals equation? The y equals. Opening up and down is the y equals equation. So automatically, I already know how to do this. I just had to read a graph to literally check how many steps I am away from the vertex to the focus. So we would plug in that number 5, which was the steps away we were from the vertex. 1 over 4 times 5 is 1 over 20 x squared. That's it. Since that number in the very front is a fraction, this is a bonus question here, actually worth a quick buck, so raise your hand if you think you got it. Is that a vertical stretch or a vertical shrink?
Vertical
Vertical
stretch.
shrink. Vertical shrink.
Vertical stretch.
Wow, we said raise our hand and we all just yelled. It is a vertical shrink
Yeah.
because it's getting wider, so it's shrinking towards the x-axis. Fraction numbers in front make it shrink. Big numbers in the front make it stretch. We'll try again on the next one. Okay, there is a problem with this last example. What is it?
Don't have no focus.
If Yeah, well, first of all, it's an X because it opens side to side. That's actually a really great recognition. So we know we're going to use this one because it opens side to side. That's actually fabulous to recognize. Okay, but we've been focusing on the focus this whole time. Is there a focus?
No.
Oh, no. So we need to remember the relationship between focus and directrix. They are the same distance away from the vertex. So reading this graph right here, how far away from the vertex is that directrix? Sort of like, it's a little bit more than half. -7/12. That's how far away it is. Okay? But when we think about how far away something is, let me draw this a little bit better. When we think about how far away something is, we're talking about a distance. Can distance ever be negative? Like if I measure something, can I measure it that? It's -3 miles long. No, that's not a thing. So I'm measuring distance. P is always going to be the positive side of that directrix. Yeah, so P's are always opposite of the directrix, and they're exactly the same as the vertex. So this is going to be just positive 7/12. The directrix is the opposite. Say that sentence one time. The directrix is the opposite. Great, so you change the sign of the directrix because the focus is the opposite sign. And now we can focus on the focus. The focus of this graph would be like right here at the coordinate point 7/12, 0, just the opposite number from the directrix. But the main idea here is if we have found P, which is the opposite of the directrix, or the number in the focus, all we have to do is plug it in. And like, yeah, we're plugging in the number 7/12 into a fraction. No big deal. That's why they make calculators. What is 1/4 times 7/12? We just consult a calculator on that one because it's kind of a gnarly amount of math. This would be 3/7 times y squared. I hear the hold on. What's up? So when you have ugly fractions like this, just consult a calculator. Because sometimes they're nice and pretty, like 1/4 times 5, that first example, and sometimes they're gnarly like this. Now here's where this focus and directrix stuff gets really, really interesting. Whenever we put it in real life, y'all ever seen those guys standing on the side of like a football game with these like sound machines? Y'all seen those before? If you ever watch NFL, next time you watch NFL, you see those guys, they're sound guys. You know how when you watch NFL on TV, you hear like the hits and like, you know, them running and like breathing and all that stuff, sport. Okay, that's because those are called parabolic sound reflectors. Parabolic because it has to do with a parabola. So this is what we're actually working with. Satellites, sound machines, all of those things that, you know how a dish, like a satellite dish, looks like a little bowl? It's parabolic. It's a parabola. So we can answer some questions about these things in real life. It says, the cross-section of a parabolic sound reflector at the Olympics has a diameter of 20 inches and is 25 inches deep. Write an equation that represents this cross-section of the reflector with its vertex at 0, 0, and its focus on the left of the vertex. That's a lot of info, so let's just graph a picture of it so we can know what we're talking about. If the focus is on the left of the vertex, and the vertex is at 0, 0, is this going to be a facing up, facing down, facing left, or facing right parabola? Remember that the focus has to be inside of the parabola. So if my focus is somewhere here, because it's on the left of that vertex, this has to open to the left, because the focus is always inside. There's my parabolic sound reflector. Okay, I kind of drew mine kind of bad. So it cuts off right here at the end. It would look, you know, like, pretend that's 3D image of a parabolic sound reflector. The other two numbers this problem gives us says it has a diameter of 20 inches. I know not all of us have taken geometry yet, but what is a diameter? It has to do with a circle. That one's the radius. So the diameter is actually the whole distance. So if we were going to label this, all of this right here would be 20 inches. The other number I have is that it is 25 inches deep, which means this dish is 25 inches. oh, if the dish is 25 inches deep, how far away is that focus from the vertex? How far away is 25? The focus, if that dish is 25 inches deep, that means the focus is at the very end. It's 25 inches away, which means, what is my p-value?
25.
25. And which equation am I going to use? The x equals or the y equals?
The y x equals.
X equals, this is going to be x equals 1 over 4 p times y squared. Now, one last thing, because this is a real world problem and we're looking on the left side, this direction, is that positive numbers or negative numbers?
Positive.
When we go to the left on a number line, those are positive numbers?
Negative.
So this p distance is actually negative because we're going to the negative focus on the left side. If it had been on the right side of the vertex, it would be positive, but it's on the left side. Great. We have everything we need to write this equation. We know it starts with x equals. We know it has 1 over 4 times that p, which is left 25 units, and my y squared. What is 1 over 4 times negative 25?
100.
Negative 100 y squared. If we were to graph that, that's what that parabolic sound reflector would look like, which is pretty cool that that's something in real life. You just learned the basics of satellite programming and parabolic sound reflectors. It has everything to do with the focus and the directrix, specifically the focus, because that's what we're going to focus on. The formulas that are on the front side of this paper that we put the little stars next to are going to be the most important thing for you to have and look at while you're doing your homework today. So probably want to glue these closed and then focus on all of those equations while we're going.